So I think I'd like to start just with this image. When I started out my career, which is now longer ago than I would like to remember, the only exoplanets in the universe were in Star Trek and Star Wars. And in the mid-1990s, when I was then quite a mature scientist with my research program, along came this field of exoplanets, and I thought it was really exciting. But I kind of established myself, and I didn't really want to change, although I was really interested in it. So I've never been an exoplanet scientist until I discovered that white dwarfs are eating them for breakfast. So I've come back into it via a slightly weird route. But this is not real data, clearly. It's a simulation. It's a simulation of what the solar system would look like with a coronagraph from a distance of 30 parsecs. So if you were flying out into the galaxy and looking back at the solar system, this is what you would see with an 8-meter telescope. And it's quite remarkable. In the visible band, because you've got good spatial resolution, you could see Earth, you could actually even see Venus, and Saturn and Jupiter. You can't see Mars because it's too faint, a bit smaller, and it's not as bright. We can build a telescope that will actually do this for real, looking at other stars in our own galaxy. And this is what Habitable Worlds Observatory is about. It's about setting up the experiment to search for Earth-like planets, to find several hundred candidates in the nearby interstellar space within a few tens of parsecs, and then to go back and take spectra. And what you get from those spectra will be, we hope, the smoking gun that tells you whether or not life is active on those planets. All we have to do is build it. We actually have most of the technology to hand. For me, this is a tremendously exciting thing. I think it's one of the greatest scientific questions of the age. And to have virtually within our grasp, except for the ability to organize the construction of the telescope, these results is absolutely fantastic. So Paul started to sell it for me, so I'm going to try and sell it a bit more. But we do have an opportunity in the UK to be part of this project. And we are developing a community to actually deliver on that. So I'm really grateful to being asked to come along and talk about it. So it's really a gigantic advert for everybody to come and get involved in Habitable Worlds Observatory. And what I'm going to do in the next few slides is just flesh that out about what we think we might do and how we're going to do it. So I'll say a little bit more about what it is. I've already started that. I'll talk about how we got to where we are now, the history and the selection process, because this is a real space mission with money. There's quite an important European and UK context to how this came about, and then I'll finish off with the current activities that we're carrying out now and what we need to do in the future. So in summary, Habitable Worlds Observatory, or HWO, it's a bit of a mouthful, is the next NASA flagship mission. We've all been through Hubble. Hubble was the making of my career when it launched in 1990, and I started using the data from it. And since then, we've had the long, slow, painful process of getting Webb into space, and hopefully in a couple of years, we'll have Roman up there too. A series of what are called great observatories. Expensive things, but you only have to look back at what the science that's come out of Hubble and the science that's now coming out from Webb to understand actually that's really good value for what we get out of them. The coverage of HWO is going to be very similar to Hubble. It's going to be UV optical and near infrared. That's an advantage because we don't have to build the massive great sunshade that cools down the Webb telescope or allows the Webb telescope to be cooled, which does simplify things. The defining science is going to be the search for exo-Earths, but it will be an observatory. It's not just about that, which will be an important program, but it will be a true observatory with many other science goals. For example, studying the growth of galaxies in the universe, observing stellar systems like those white dwarfs that I like to study that are eating extrasolar planets, and also our own solar system. As always, in these projects, it will be an international project. Nobody's signed up yet, but we're in the early phases of doing that little dance around, okay, who wants to be in, who doesn't want to be in, if you're in, what are you going to do, how much are you going to put in? So we're at a really critical stage of defining the project. So the development is starting now. Launch is officially no earlier than 2040. Well, we've all been there with Webb. If we hit 2040, it'll be a miracle. But it is only 15 years away. It's not so far in the future. In the European context, there's a lot going for us. We have a vibrant exoplanet research community now, starting from nothing in 1995. We have a range of space missions, ESA's CHAOPS mission. We're building Plato and Ariel, which will be launched in the next few years. We already have a key role in James Webb Space Telescope. And these are going to provide our science community with a lot of data. They may provide Earth-like candidates, but only if the winds are blowing exactly in the right direction at the right time when you do the observations. And if we do find Earth-like candidates, the follow-up is really, really hard, if not impossible with these instruments. So there is a need to go a step further and design an instrument that's actually going to do those follow-up observations. The route to Habitable Worlds Observatory through the NASA Decadal, or the US Decadal Survey, with studies such as the Louvois study that I was involved in and several studies before that. So we've been working on this for 10 years already, I would say. Also a mission called HabEx, which were part of the route to the Decadal Survey. Lots of observers from Europe involved in those. I was the UK representative on that. Also Kines, so we've got to keep a close eye on our potential rivals here, sponsored an instrument study for the Louvois mission, which will be a UV spectropolarimeter, and that's just being revived right now with should we say, a re-kickoff meeting planned for early January. We also put in a white paper submission to Voyage 2050 to get this on the table within ESA, and ESA were very receptive of that. So we're bringing people together, and that's the important thing, it's creating the community. So the process of the Decadal Survey, they were told to try not to make the same mistakes that they made with Webb. I won't go over those. We can talk about that over drinks later if you want to really know. But to try to avoid some of the problems of a mission that's not correctly formulated and therefore gets more expensive and takes longer, NASA were instructed to carry out a number of studies prior to the Decadal Survey, Louvois, HabEx 2, but also LINX, an X-ray mission, and Origins far infrared telescope. All those went into the mix to be reviewed by the panel, and the outcome of the panel deliberations at the end of the sort of teens was that there should be a new generation of flagship observatories funded by NASA, a UV optical infrared and a far infrared and an X-ray observatory. But the first mission out of the blocks is going to be the Habitable Worlds Observatory, which is effectively a merger of Louvois and HabEx. We don't know exactly what it's going to be. That's what we're trying to define right now through the activities that are going on. But it will be a round 6 to 8 meter aperture telescope, segmented telescope based on James Webb heritage. It will have a coronagraph. The coronagraph is going to be trialed on Roman, and that's a real challenge. The contrast factor for the coronagraph needs to be 10 to the 10, which is about 10 to the 5 times better than anybody's done so far. So there are some real technology challenges here. But NASA has begun working on that technology through what's called the GOMAP program, which started at the beginning of 24, which was designed to create a set of science example cases, and then to use those cases to define the demands on the instrumentation, and then to look at what the technology drivers are going to be, to try and shortcut some of the rather long-winded processes that got Webb to where it is now. So the GOMAP was implemented in January, and that includes creation of a number of working groups to develop those science cases and identify technologies. There are many UK contributions in those. I'm co-chair of one of the sub-working groups working on stellar populations, and quite a few people in the UK have either co-chaired subgroups or have been members of steering committees. So there's good roles going on there. What really surprised everybody is that around about May, June time, Congress just said, okay, do it. In the sense that they said, here's some money, create a project office, start the project. And so this rather informal, not very well funded activity, the Start GoMap activity, translated very quickly into the establishment of the NASA Project Office, which is now up and running and is starting to deliver the Habitable Worlds Observatory program. The science case work will continue into the end of this year and early next year, and then there's a real landmark point in July next year where there'll be an open science meeting to which everybody can go on the East Coast somewhere, to be decided, to actually look at all the science that we think we can do with this great observatory. I'm not going to go through this in detail, but this is a quick summary of the kind of working groups that were set up to address science on the left-hand side and the systems and the technology on the right. So, as I said at the beginning, we don't really know what this telescope is going to look like because we need to know what the science drivers are. But on the other hand, it's a little bit of a chicken and egg. You've got to tell people thinking about science a little bit about what they might get, so that you've then got a gigantic loop where you try to close everything together. So to meet that, at the moment, there are 3 designs under study, all around about the same aperture, and there'll be 4 instruments we expect on those. These are the mission parameters. But what I want to cover really is what can we do. So this is a quick summary of the kind of instruments we might be looking at. Coronagraph is going to be very important with a spectrometer to actually look at those Earth-like planet atmospheres. But also other things for doing the wider range of science like multi-object spectroscopy in the UV and high definition imaging. So the UK interest is very strong. You heard it from Paul. I don't need to say it now. I was actually wondering whether I dared say that the UK Space Agency is right behind this mission. HW always liked it to be the high-profile space mission, at least in astronomy terms, of the 2040s. I think it's also the most likely facility to actually find life. I think other things like ExoMars are great, but they can only go to one relatively limited location. Habitable Worlds Observatory can survey the nearby systems in our galaxy and look at hundreds of examples, carry out the real experiment about how common life might be. What might we do in the UK? We don't know yet because we have to work it out, but we're thinking up front that we'll be modeling it on an approach a bit like MIRI, maybe leading an instrument consortium. But also there are other things we might contribute. One of the reasons I want to come and talk about this today is because we have a diverse audience here from industry as well as academia. And what we want is people thinking about, well, what can my company do with this? Because there are going to be a lot of opportunities for providing niche technologies that support the entire mission, not just supporting an instrument that the UK might provide. And we want the greatest coverage of activity across the UK that we can achieve. So we've had a couple of workshops. Paul referred to it, so I won't go into great detail about that. But the mood music is going well. We've had a number of visits from senior NASA people, Nikki Fox, Mark Clempin, and Mackenzie Lystrock most recently, who are all talking up Habitable Worlds Observatory. They're doing that because they want UK to be involved. Obviously, they want to save some money from the NASA budget by getting some people to pay for other parts of it, but that's the way we always do these things. Technology is being discussed right now. We have a technology development plan going, and we have to look to see TRL5 on all the technologies by 2029, so we can't hang around. That's about 4 years away, really. We're at the back end of 2024. The outcome of our last workshop was very positive. We had 120 people involved in the workshop from across the UK, with a very clear steer from that group. Well, they're self-selecting, so they're bound to be interested, but very much a steer that we should start the UK project SDFC are happy to support that at a modest level. They've supported the workshops so far. And so that's the work that we're doing now. And that's why I want everybody to hear about this mission, because I want as many people in the tent as possible. So please share information about HWO developments with your colleagues. We want to create a project that's a UK-wide project that covers all communities. Please join it. If you want to know more about the detail, there are a couple of QR codes that will take you to the relevant NASA websites. We don't yet have a website of our own. I plan to do something about that. Provided SDFC give me a bit of money to do it, I'll be asking. But the important thing is that we want a large group of people across the community to contribute to developing this leading role. People are informally talking about 50 to 100 million pound contribution to this mission. Whether we'll get it, we don't know. But we'll have to sell that to government. We have to sell the science case. We have to sell the business case. But I think it's doable because this is such an exciting prospect. Why would we not want to be involved in finding life in the universe? It's the big question. So anybody wants to be involved, please email me and I'll add you to the various mailing lists and I'll collect all those names together and we'll start to create this community. Thank you.
Thank you, Martin. Yeah, I think we have one question.
Thanks, Martin. A great presentation, of course. And it's a fantastic scientific objective and one that we've sort of been waiting for to be ready to do. So this is an engineer's question, so it's not designed to derail anything.
Quite fine.
But 20 years ago, the idea was to build a distributed infrared interferometer to tackle this challenge. And it's the curious thing that today Proba 3 has been launched to demonstrate formation flying. So is there a reason that I can understand why all the ideas about building an infrared interferometer to tackle this science challenge have been abandoned and we've gone back to a giant monster spacecraft, which also looks very cool?
It's part of the technological challenge of doing formation flying to the precision required, which we can't yet do.
It's being done now, isn't it?
Well, it's being tried.
Yeah.
Okay.
Let's try that.
We'll find out what the challenges really are. And of course, the scale of things is different. The other part of the answer is that the access to the UV and optical for understanding what's going on in the planetary atmospheres is absolutely critical. That's where you find ozone, oxygen, and methane. So if you're looking at sort of protean type Earth-like atmospheres, you really need the optical and the UV and the visible and the near infrared, which you won't get from those far infrared missions.
How important do you think it is right at this moment? There are two Brits in really key positions in NASA, Nicky Fox and Mark Crane.
I think it helps a lot because, not because they've got any particular axe to grind, because obviously they are two Brits, but they're also US citizens now, otherwise they wouldn't be in those key positions. But they do have an affinity with what's going on in the UK, but it's actually partly because we've worked on these other projects for decades. Brits have been part of Hubble, a lot of us have been part of James Webb, and so that track record is showing to NASA, and in the end we've got to demonstrate that we can deliver, that we can do this kind of thing. So it's helpful, but I think it's more how we demonstrate our record. And one thing I would say, which Paul was here, so he could hear me say it. One of the reasons that they're talking to us so much is that the agency has really established its credibility in recent years with its programs like its bilateral program. And NASA have woken up and said, oh yeah, the Brits can actually deliver this stuff. So we actually need them on board. So it's a bit of both. What these people like about the UK, but also what we've done for ourselves to demonstrate that we can deliver this.
I have a question myself, actually, as a science communicator perspective. I'm aware of workshops going on around preparing public communication and outreach and awareness for potentially discovering life. This would be massive, and I know Jonathan Amos as well, you'd be interested in this. So in part of forming working groups, is there communications and engagement activities already being thought of?
Yeah.
With all due respect, more than just a website.
Yeah, there are there are communications working group within that structure. I have had no involvement with it, so I don't know what they've been talking about. But in the workshops that we've held, although we haven't addressed it very deeply yet, we've had some discussion about it because it's clearly a really important question. And going into the sociological impact and societal impact of actually having knowledge or not that there's life elsewhere. I mean, we might not find any, but that's an equally valid result, and we have to communicate that as well. So I think we'll start to pick that up. At the moment, we've got a bit of a focus to try to get the technology underway, but we shouldn't push that into the backwater. I think it's good if people are starting to think about that. In Leicester, we have more people we're growing people who are not in the engineering side of space, like law, social science and things like that, and they've got an interest, and I'm hoping that space broadens out into those communities, and those communities will pick up some of these questions. And let's be honest, get money from another funder to actually pay for it.
Hi. Yeah.
Go ahead.
As a technologist, I want to ask which will be the strongest takeaway from James Webb to SW?
Sorry, I think I catch that.
Strongest takeaway technology from James Webb to SW?
Okay, so the mirror, the deployment stuff is absolutely critical because we demonstrated that we can fold up a really large mirror, deploy it in space, and focus it and use it. There is a bigger challenge, though, that James Webb is infrared, and the precision and the maintenance of the wavefront for a UV optical telescope is much more demanding, as is the optics. And actually, that's an area where the UK might play a strong role because we have really top-class optical companies in the UK who can answer some of these questions. So it's the complexity of James Webb that I think is the big win. But there's more work to do.
One more question, and then the rest during tonight's dinner.
Hi, I just had a question about the technology development. When Dr. Mackenzie Listrop came to Rail Space, she mentioned that we needed about 10 miracles of technology for this. And when you did your talk, you mentioned that a lot of these technologies are right in front of us. And I was just wondering what you think about how likely these technologies are to be able to be developed in time for the 2040s.
Well, I don't know about all the technologies, but I can see routes this. So precise wavefront correction of segmented mirrors, we're already doing that for the extremely large telescope. So those technologies are under development and already quite mature. From the point of view of the super smooth mirrors and precision of polishing, we've got a company in the Midlands called Zico, who are being funded by Innovate UK to manufacture complex optics to high precision. And they're building a whole new generation of machines to do that. So that's the route there. So there are routes. I don't know if I could resolve all those technologies for NASA, but there are things going on, and we need to identify the things that are not going on that need to get some investment so that we can move them forward. Coronagraph is really critical, obviously. That's probably not something we would do because the Americans in Space Telescope Institute have been doing that for a long time, and they're really pushing on the boundaries of what you can do and what contrast you can get.